So I'm gonna leave a little bit of space here, okay? And today we're actually gonna start talking about those things that we weren't able to do previously, okay? So I'm gonna leave a little bit of space because we're gonna put a caption up there, but not yet. So here's example 1. Okay, we're just gonna kind of look at it. So what I want you guys to do is we are gonna be integrating 2x times x squared plus 1 to the second power dx. Okay? So, ladies and gentlemen, we could, if we really wanted to, we could multiply all that out. We could, FOIL it, then distribute a 2x, and then integrate. However, there is, I wouldn't necessarily call it an easier way, but it is a faster way, as long as we understand the rule. So, typically, what you want to do, and I say typically because it's not an end-all, be-all rule. You let U, and we'll talk about what that means, be an, I'm going to put quote-unquote inside function. Okay? So, see how this says substitution here? Okay. What this means is I'm going to take something out of this function and replace it with something else. Now, if you guys were to look at this, does anyone see an inside function? Yeah, you guys are kind of used to it from chain rule, right? Like I always say, look for the inside function. So here, what I would say is let U be the inside function, which is x squared plus 1. Now, the whole reason for doing this is to integrate a function that is way easier. But the problem is, if I replace this with U, I still have a 2x here and I still have a dx here, right? Do you guys see what I'm talking about? So what can I do to get rid of the 2x and the dx? Well, here's what I'm going to do. What's the derivative of U? 2x. Not plus x, but you integrated. So 2x dx. Okay. And the derivative of U is du. So let's just kind of follow what I did. Do we all agree? If I take a derivative of U, it would be 1. But I have to say that it's a derivative, so I put du. Make sense? The derivative of x squared is 2x. And because I took a derivative of x, I'm going to put dx. So far, so good? Okay. So let's talk about some things that get replaced. This 2x and this dx will be replaced by a what? By a du. You guys okay? Okay. So that means I'm going to be integrating. Here's du. That 2x and dx is gone. What am I going to put in the place of x squared plus 1? U. But remember, it's x squared plus 1 squared, so this is actually going to be u squared. And now as we look at this, way easier to integrate than what I had previously. Okay? So let's go through. Let's integrate this variable. I have everything has the right terms because I have u's and I have du's. So if I integrate, what is this going to become? 1/3 u cubed, and because it's not bounded, I have to put plus c. But typically this is not what they want, right? Man, I wish I knew what u was. Oh wait.
We do.
We do. U is up here. So because we already know what u is, you replace it. So I'm going to have 1/3 parentheses, x squared plus 1 to the third power plus c. That's what happens when I would integrate that function. That's what I would have gotten.
So that's your final answer?
That's your final answer.
Would it be F? Capital F?
It would be capital F of x. Okay? Because I integrated a function of x. You guys okay? All right.
We can just leave it.
You can.
I like the feeling.
Okay. All right.
Oh, it's going to get real freaking hard.
So let's look at example 2.
Alright, here, Trig screaming.
You hear Trig screaming your name? Yeah.
Alright.
Not yet.
Oh, I was just saying.
Guys, like I said, I'm going to start off easier and then I build it.
Well, the other day you just jumped right into trade.
Okay, sorry. So we will be integrating x, parentheses, x squared plus 1 to the second power dx. Looks super similar to before, correct? Okay. So what's our inside function? Okay, so we probably want to let u be x squared plus 1, and since I'm already over here, let's take a derivative. So derivative of u will just be du. Ooh, sorry. What's going on there? What's the derivative of x squared? 2x, but we have to also put not plus c. No. dx. Okay? So that's what I'm saying. Guys, you have to understand, are you taking derivative or are you integrating? Here I'm taking derivative. I need to state it's a derivative. Okay? So, as I look over here, this x squared plus 1 is taken care of, correct? I can replace this with u. I have a dx, which is great because I have a dx over here. However, notice I only have a what here? An x. Okay, so there's one way I can teach it, and I'm not sure. No, it's not. What do I want this to look like on this side? What do I only want on this side? I want x dx. So what needs to move? How can I move that to the other side? Divide by 2. So what you really get is you just get 1/2 du equals x dx. Okay? Nothing, all I did is I just added a factor, and that's okay. It's not going to change it. So let's just think about what I have. If I replace x dx, what do I have to replace it with? 1/2 du. If I want to replace x squared plus 1, what goes in there? U squared. Now, you might not like the way this looks, so what would you guys rather do? Where would you rather have that 1/2? Yeah, in front of everything. You can do that. This is completely legal. Okay, I divided by 2. I said that x dx was equal to 1/2 du. There's no x's there, so I don't have to worry about crossing my variables, right? So now let's just integrate it. So I have u to the third. I also have a 1/2 here. I'm dividing by also what? 3. So what's the reciprocal of 3? It's another way to think about it. 1/3. Okay. Do I need to plus add c or not?
Yeah.
Why?
Not
Not bounded. Yep. So as I go through and replace this, do I know what 1/2 times 1/3 is? Please say yes. It's 1/6. What's u? X squared plus 1 to the third plus c. Guys, just notice the subtle difference in the previous. Here, I got rid of the 2. That's the only difference. I divided here, and this is the only difference. And it just changed it a little bit. Okay? So what we're going to be looking for is what's in my integral that I need to replace with whatever I have on this side. Okay? That's the trick with what we're doing today. So let's bring it back a little bit. So example 3, as I look at this function, integrating radical 2x minus 1 dx. Okay. I need you guys to think, what's the inside function? Yeah, 2x minus 1. So if u is 2x minus 1, what's du? Just 2 dx. We cannot forget the dx. So as I look over here, what can I replace 2x minus 1 with? I can replace this with u, but see how this dx is by itself? Is this dx by itself? No. So what do I need to do? Divide by 2. So I get 1/2 du equals dx. And again, as I set up my integral, I'm going to replace 2x minus 1 with radical u times 1/2 du. You guys okay? Okay, so maybe you want to move it to the front, and I'm actually going to change that radical to a what? Yeah, I'm going to change it to a rational exponent. I would, so you do your power rule correctly. So 1/2, what's my new exponent if I integrate it? It would be, what's 1/2 plus 1? 3/2, but what's the reciprocal of 3/2? 2/3. Do I need to add a c? In this case, I do. Okay. So now I'm going to go through. We see that our 2's cancel. You're actually left with 1/3. My u is again 2x minus 1 to the 3/2 plus c. And that is your integrated function. Oops, that you guys can't see. Sorry. Okay. No, not yet. Okay. You're so negative, Nancy. Just calm down. And guys, unfortunately, the only way to get really good at this is practice. You can't just magically look at it one day and be like, oh, I get it. Yeah, no.
I get it.
Okay.
I'm ready for that time.
I think you're misunderstanding. I have 5 pages of notes on this. You're not ready yet.
Okay.
Triple substitution.
No. Okay. So ladies and gentlemen, if you can't read this, it says x cubed divided by radical 1 plus x to the 4th. So the hard part with u substitution is even understanding what the function is that you want to let u equal. So I'm telling you the trick to this is try and find the inside function. What's the inside function? So we're going to say u is equal to 1 plus x to the 4th. But again, I can't have dx as I need a du. So what is du equal to? Not x cubed. 4x cubed. We're just taking a derivative. 4x cubed dx. Okay. So hopefully you guys are seeing something kind of nice here. I'm going to take care of this 1 plus x to the 4th with what? With u. However, what's hanging out up here? X cubed. What else is also hanging out with it? dx.
Divide by 4.
So all I need to do is divide by 4, and then I can take out x cubed and dx and replace it with 1/4 du equals x cubed dx. You guys okay?
Yes, we can.
No, not always. That's what I'm telling you guys. I'm giving you the easier ones first. Okay? So let's just do the 1/4 du off to the side. Let's figure out what does this look like. Okay, it would look like 1 over radical u, but I am going to use that u to the negative 1/2, so I don't have to use a quotient, something that you guys don't know how to do. Okay? So I am going to make this as u to the negative 1/2. You guys follow? Ooh, no, maybe not. You guys follow that math? Okay? This x cubed and dx is taking care of this 1/4 du. And then here, because it's in a denominator, I'm going to move it up to negative 1/2. If you want to rewrite some stuff to make it look better, I don't care. Just don't forget about that 1/4 because it would give you an incorrect answer if you left it off. All right. So I have a 1/4 out front. Negative 1/2 plus 1 is 1/2. The reciprocal of 1/2 that I need to multiply by is 2 over 1. Do I need a c? Yes. So we're going to go through. We're going to clean it up. 2 over 4 is actually just 1/2. I'm going to replace u with 1 plus x to the 4th, so 1/2 plus c, and I am done. Okay, so the question happened. what happens when du does not, quote unquote, cancel nicely? You guys literally just asked that question. Will it always work out this well? Nope. Okay. So, I actually showed Brendan this yesterday. Example 5. Okay, so let's just look at the integral. Let's try and figure out. And guys, sometimes you'll pick a u and it was the wrong u to pick, so you'll have to start over again. Okay. So, radical 2x, x times radical 2x minus 1 dx. Okay. So, let's try the same thought process. What's the inside function? Okay, so let's try it with u equaling 2x minus 1.
Wait, does you equal something else?
No.
Oh, okay.
I'm just saying, in this case it does, but sometimes you guys will try it on your homework, and you'll be like, this didn't work. You'll have to try something else. Okay? So, next step is to find du. What is du? Snickerdoodles. Okay? What's our problem? There's no x. Okay? There's no x. There's literally no x that I can cancel out with that dx. Do you guys see it? I can't do it. However, look at the above equation. Look here. What do you have here? You have a u and you have an x. You guys are really good at it back in algebra. What could you do instead of having this u be u equals? Have it be x equals.
Whoa.
Okay. So what you're going to do is you're going to take this equation so that I can replace this x with whatever u is. Okay? So, first step would be to add 1, right? And then the next step would be to divide everything by 2. So therefore, I get that x is equal to u plus 1 over 2. Now, the question is, do I need to find the derivative? Did I already take care of a dx in this case? I did. So no, you would not need to find a derivative because I already have a du and a dx to take care of each other. It would, but you wouldn't want to plug it in twice. Okay? So you have 1/2 du equals dx. Okay, I think everyone understands that. I also have that x is equal to this. I can also replace 2x minus 1 with a u. So let's just follow this piece by piece. Okay? I'm going to integrate. What does x equal? Okay. So u plus 1 over 2. What does 2x minus 1 equal? So, yeah, radical u. And what does dx equal? 1/2 du. Okay, I'm going to do some craziness that you guys are not going to like, but I promise it works. Now, you see this 1/2? This is technically a 1/2 as well.
So I just cancel.
No.
No, it's 1/4.
It would be 1/4. And we haven't done it yet, but we're allowed to do this. We can do 1/4 integral.
What?
U plus 1, u to the 1/2 du. Because guys, think about it. I'm multiplying by this, right? A multiple does not change how you integrate a variable. Okay? So, I still can't integrate it the way I see it. What do we have to do? What do we have to do here? You can't integrate this yet.
We have to choose another.
No.
Okay, sorry. Plug into
Guys, you have to distribute.
Oh.
Okay? You can't integrate it the way that you have it. You don't know how to integrate something when you're multiplying it. So we're going to make this u to what power then? 3 over 2 plus u to the 1/2. And again, I have my du taken care of. That 1/4 can stay out front. So now, as I integrate it, here's 1/4, big parentheses. What happens with this right here. It's now going to become u to what power? 5 halves, which means my coefficient is the reciprocal, which is 2/5, plus, when I integrate u to the 1/2, I get u to the 3/2. My reciprocal is 2/3. I can close my parentheses, and because it was not bounded, what do you need? Plus c. Are you done?
No.
No, the last step.
Plug in.
Plug in.
I don't like all of it.
I don't like you.
That's pretty accurate. That's nice.
It's just long.
I told you. Okay. Okay.
Oh, no, you simplify it.
You don't have to simplify. That's a final answer.
In college, will we have to simplify?
No,
Okay.
it's not necessary.
What?
Okay. All right. How much time is passed? All right. Guys, we're not done, but I'm going to stop this for a second.